Okay, so last we discussed vertical circle, tension formula, velocity formula. And now what we'll discuss is what is the minimum speed required to complete the vertical circle. Okay. So the object is here. This is point A. This is point B. This is point C. This is point D. Okay. So we have UA here. And we calculated in terms of theta. Right? At any point, what will be the velocity? Okay. At any point, what will be the velocity we calculated? So this is point A, and this is in general. Already we discussed it, right? Now, we want it to complete the vertical circle. We want to complete vertical circle. So if it has to complete the vertical circle, we will come back at point C. So C point is becoming very important. Okay. To complete vertical circle, point C is most important. Okay. So point C we have to concentrate, because if it is crossing point C, then of course it will complete the vertical circle. So point C we have to reach, right? So we have to modify the formula. Which formula we have to modify? Which we already got last time. Let's go to that formula. What is that formula we discussed here? So in this, what we are going to do, we will put here theta is equal to 180 degree. Theta is 180 degree. If theta is 180 degree here, it will come back at point C. Because see, when theta is 90, it will go to B. When theta is 180, when it will come here, then only it will reach at C. So theta is 180, what we'll write? We'll write VC square is equal to UA square minus 2GL. Theta is 180. So cos 180 minus 1. 1 minus minus 1. 1 minus minus 1. So it will be 2. So it will be UA square minus 2GL. 1 plus 1, it will be 2. So how much it will be? It will be equal to UA square minus 4GL. Okay. This will be for VC. Similarly, what will the tension value? TC. mg. Theta is 180 degree. Cos 180 minus 1. So 3 into minus 1. Minus 2 plus mu square by L. Or we can write this as MUA square by L minus 5 mg. Okay, minus 3, minus 2, 5 mg. This will be TC. So now both the value is for point C. Both the value is for point C. This already we discussed T value and VA value calculation in the last video. So this one TC and VC we are calculating, right? So TC and VC value we have to utilize now in this. So TC value. Okay, tension at point C. How much we calculated? What was the value? TC value. mu square by L minus 5 mg. Remember one thing, if you have any doubt, mass into centripetal acceleration at A minus 5 mg. That will be there. Okay. So m u square by L minus 5 mg. Okay. And VC square. What was the VC square value? UA square minus 4GL. Okay. So now we have a value exactly at point C. Now TC is m u square by L minus 5 mg, VC square is u square minus 4gl. Now we are saying that minimum possible value we need at C. Minimum possible value. Suppose we'll make velocity at 0 at C. If VC is 0, what will happen? If VC is 0. What happens if VC is 0? If suddenly something is moving, it stops. What will happen? It will directly fall from C towards O. And finally, maybe it will cross A also. Means it will go in this direction. So when we are going for minimum condition, we cannot say VC as 0. Because the moment we'll say VC and 0, forget about the circle. It is just a free fall then. Because if VC is 0, right, suddenly it will drop down. Okay. And in fact, if VC is 0, tension will also be 0. Why tension will be 0? If you remember, we discussed the previous slides. So if VC is 0, it will drop down. So what will the second case? Second case will be if the second condition which we have to think is TC is equal to 0. Remember, VC and TC 0 is two different conditions. So this is case 1, this is case 2. TC is 0. Now, if TC is 0, will the VC becoming 0? So let's first calculate if TC is 0, what will happen? If TC is 0, then 0 is equal to m u square by L minus 5 mg. From here, what will be u square value? U square will be root under 5 GL. Okay, this is the value. But if you put root under 5G value, VC square GL minus 4GL, still it will be GL. So it's not 0. So when TC is 0, VC is not 0. Meaning of that is, even if tension for the time being 0 and we are calculating a minimum possible speed at A for doing so, VC is still non-zero. Meaning of that is, it will not fall vertically. It will continue with the journey slightly. Okay, it will move in this direction. And the good thing is, the moment it will move in this direction, again, tension will be developed. It will no longer will be 0 after that, right? And hence it can complete the vertical circle. So we can say that for completing vertical circle, tension has to be 0 and VC of course is non-zero. Both cannot be simultaneously 0 because values will be different. Okay. So root under 5GL, if will give in this vertical circle, it will complete, right? It will complete this vertical circle. So root under 5GL. This is the velocity which object has to get at point A to complete vertical circle. To complete vertical circle, object has to get this velocity at A, and corresponding, of course, at VC, corresponding speed will be root under GL, corresponding. So if you'll give root under 5GL at point A, then it will reach at C, and C velocity will be root under GL. Tension for the moment at exactly at C. Remember, it will be at C only for a moment. That moment, tension will be becoming 0. And subsequent motions, subsequent moment, again it will come back with non-zero value. So this is the minimum speed required for this one. Okay. Now, the second case rise in this one. Suppose it is not able to reach C. If velocity is less than root under 5 GL. Minimum requirement is this. This is the minimum speed. If we'll give this much, okay, it will complete the vertical circle. Suppose it is less than this. Now, less than this value can be anything. At A, we can give any velocity less than this. Even root under 3 GL, root under 4 GL, root under 2.5 GL, anything less than root under 5 GL, there are infinite values. Right? Minimum is root under 5 GL to reach C and more than this. So to complete this vertical circle, UA should be greater than equal to root under 5 GL. Okay. To complete vertical circle. Okay. But if it is less than this, then what will happen? Now, if it is less than this, there are two cases. If it is less than this, there are two cases that we have to discuss. Right? If it is less than this, now it can reach B. Now, next point of discussion will be whether it will be able to reach B or not. Will it leave the B or will it before B it will leave or after B it will leave? Now, the second thing will be that. So, B become a crucial one. Suppose after B it is leaving, it is moving like a projectile. Before B, if it will leave, it will keep oscillation. Okay. After B, it will move like a projectile. Before B, it will oscillate. So B become crucial. So now what we have to do is we have to concentrate on point B. And we have to calculate what will happen at B. But good thing about B is if you look at point B here, it's very simple point. In the sense, calculation is quite easy. Suppose here velocity is given as UA. Here speed is VB, right? We can directly write half m u square kinetic energy at point A plus potential energy at A is equal to kinetic energy at B plus potential energy at B. So mgl. From here VB square we can directly calculate. Mm will get cancelled. We can write UA square is equal to UB square plus 2GL. Okay. And at this point, if you'll see tension and mg, let's talk about the forces. They are perpendicular. In fact, tension is not giving any centripetal acceleration because tension is perpendicular to the line OB. So mg has no contribution towards centripetal acceleration. So it is the responsibility of only tension. So we can write tension is the centripetal force, only centripetal force, which will be equal to m VB square by L. So tension is the only centripetal force available there. Right? So if VB is 0, tension will also be 0. Meaning of that at point B, unlike at point C, at point B, both velocity and tension will simultaneously be 0. If one is 0, if tension is 0, velocity will also be 0. Right? If tension is 0, velocity will also be 0. So what can be the minimum velocity using this? We can say that minimum, just limiting case, just to reach there, minimum can be equal to something like 0.0000000000001 meter per second, which is approximately equal to how much? It is approximately 0 itself. So we can say just to reach at point B, just to reach at point B. Minimum speed we can give is 0. In that case, what should be the speed at A? It will be 0 square plus 2gl, which will be 2gl, or UA minimum will be root under 2g. Okay. UA minimum will be root under 2g. Now, if minimum is this much, root under 2gl, right? It means if the velocity is more than root under 2gl, it will cross B. If it is less than root under 2gl, it will not able to cross B. So it's very simple now. There are 3 components. If velocity is at A is between 0 and root under 2dl, it will oscillate. Oscillation will happen. If it is greater than root 2gl, but less than root 5gl, it will be leaving the circle, but it will move like a projectile. But if it is greater than root under 5gl, we can say that it will complete vertical. It will complete vertical circle. Okay. It will complete vertical circle. So we have to understand here in 2 parts. To reach point C, minimum is root under 5gl. To reach point B, minimum is root under 2gl, right? So if you want to reach B, it has to be root under 2gl. If it is in between, it will not reach B. It will keep oscillating. Keep oscillating between B and D. Oscillation will happen. If it is more than root under 2gl, it will move like projectile. And if it is more than root under 5gl, it will complete vertical circle. Okay. So this is what we have to understand here. Okay.